All right, so starting over. So we got, it's this part that we didn't do. We didn't do page 54. We did 55 and 56 on the front. So on that part, now I also didn't have you do problems 14 through 20. So you don't need those answers. You just need the ones I'm showing there. So for form 1, which is on page 55, the answers there are number 1 was D, 2 was F, 3 was A, 4 was G, 5 was D, 6 was G, 7 was C, 8 was G, 9 was C, 10 was H, 11 was C, 12 was F, 13 was A. And then on this front side, I also had you skip the bonus, so we didn't need that one either. That was the first set. So again, those are the correct answers. I'll go over each one here in just a minute, but those are the answers. All right, on the second page on the back, let me clear that. Here. All right, so then on the second page, this one, same thing. You're doing 1 through 13, so you didn't need answers for 14 through 20. I said you could do the bonus on this side if you wanted to. So that was, again, it wasn't really a bonus. It was just a review. So you could have done all those. Now, this was not multiple choice. So these were the answers. 1 was square root of 10. 2 was 13. 3 was 2 radical 7. 4 was square root of 4,000 or 20 square root of 10. 5 was square root of 300 or 10 square root of 3. 6 was 11 radical 2. 7 was 2 radical 3. 8 was x equals 6. Y was 12. And 9 was 9.7. 10 was 69. 11 was 68. 12 was 267.9, and 13 was 11 degrees. And then B, the bonus was 1. All right. So now I do want to go through and actually do those problems with you, but if you check your work, those are all the correct answers. Going back to the beginning. All right, so number 1, find the geometric mean between 2 and 5. So if we're doing geometric mean, we are taking the square root and of the square root of the product of 2 numbers. So we are doing the square root of 20 times 5. And 20 times 5 gives us, what was it? 100. Square root of 100 then is 10. So our answer there was D. Number 2, find x in triangle ABC. All right, so here's x. X is the altitude of this right triangle. So we're using our properties. There's an equation. It's up there on the board still. Hopefully you have memorized your equations. Altitude is equal to the square root of part 1 times part 2. Well, if I was labeling these, this could be part 1, this could be part 2. So I am just multiplying 4 and 16 and then taking the square root. So x will equal the square root of 4 times 16. 4 times 16. Now, you could make this a little bit faster. Both of those are perfect squares. So if I just went ahead and square root both of those, I'm going to save myself a little bit of time. because I can do square root of 4 and square root of 16 and have smaller values to deal with, which would be 2 and 4, which would give me 8. Now, if we didn't do that, 4 times 16 is 64. Square root of 64 is 8 as well. There's more than one way that you can do that problem, but either way, your answer is 8. Number 3, find x in triangle PQR. So here's x. Right now, it is our hypotenuse. For this one, we are using Pythagorean theorem, c squared equals a squared plus b squared. Oops. B squared. So the most important part is labeling which one is going to be our c value. Which one of those three is my c value? The hypotenuse. So where x is going to be c. These other two can represent my legs. So those are a and b. So when I plug it in, I have x squared equals a, which I'm going to plug in 5 for squared, plus b, which I'm going to plug in 12 for squared. And we have 5 squared is 25, 12 squared is 144. Add them up, you get 169. You have to get rid of the square, so I'm going to square root. And the square root of 169 is 13. Did I really have to do all that work? No. Again, it works. I did Pythagorean theorem, but there's a much shorter way. The triples. Now again, on the board, I have those triples written still. I am not leaving all that information on the board for the next test because you're supposed to know these. Actually, I'm playing with an idea. I might instead ask you on Monday at the end of class to fill out a form for equations. That way I can write some of those equations on the board and you can use them for the rest of the test. So I'm thinking I might have you guys write those out on Monday, and then that way you can use them on the rest of the test. All right, but let's see here. For number 3, if we wanted to, again, the two that I told you you should definitely memorize is a 3, 4, 5 and a 5, 12, 13. And guess what? This one was one of those two that I told you to memorize, the 5, 12, 13. So if you knew you had 5, you had 12, the missing side had to be 13. All right, number 4, find x and STU. So for this one, we have x, we have 15, we have 17. Well, again, we could do Pythagorean theorem. Do we have to? No, this is actually another one of those triples that is written on the board. This is the 8, 15, 17. So again, it could come in handy if you know more than just those first two, because the answer is already there. All right, so that missing part is 8. If you didn't do it though, you have plugged into Pythagorean theorem. Just for the purposes of demonstrating, since this was a review. Whoa, why did that just go all crazy looking? Like cord, not like plugged in all the way somewhere. I don't know. All right, that was the first time the board flickered, right? All right. All right, so on this one, if we were to plug it in to solve, we'd have 17 squared equals x squared plus 15 squared. 17 squared is, why is that board doing that? So it was, oops, I don't need a square anymore. It was 289, right? Then we had x squared plus 15 squared is 225. Subtract off the 225, you'd be left with 64. Take the square root of both sides, and x is 8. Hold on, let me check this connection over here. These two are connected. Hopefully that'll be the last flicker. was a little loose. All right. So where was that? All right, on number 5, which set of measures could represent the lengths sides of a right triangle? Well, they told us or asked us which ones could be the sides of a right triangle, and first thing I noticed is that all the values down there are whole numbers. So guess what? If it's going to represent a right triangle and all the numbers are going to be whole numbers, one of them is going to be a triple. Do we recognize any of those as being one of our triples? Which one? C, you said? C, 8, 12, 8, 10, 12. No, it's not that one. It's going to be D. Because that is our 3, 4, 5. Just multiplied by 3. All right. 8 times 3 is 9. 4 times 3 is 12. 5 times 3 is 15. Now, is that the only way to do that problem? No, but the other way would be very lengthy because you had a multiple choice here. So you would have to plug each one into Pythagorean theorem and seeing which one had a c squared value that was equal to a squared plus b squared. Again, if c squared, one of the properties here that you should know, c squared is equal to a squared plus b squared. That is for a right triangle. But if that doesn't work out, so you plugged all those numbers in and you didn't get c squared equal to, then you may have got c squared is less than a squared plus b squared, which gives you an acute triangle, or c squared is greater than a squared plus b squared, would have given you an obtuse triangle. And again, I could ask you to say what each triangle is, and that's more likely the way I'd ask that on a test. So instead of giving all those options, I'd give the options as either right, acute, or obtuse, or none of the above. How would a triangle not be possible given 3 measures? All the ones down there are triangles, but how would it be possible to be given 3 numbers and wouldn't it be a triangle? Any 2 sides of a triangle have to be greater than the third side. So if you add the 2 smallest and they're not greater than the third side, it can't be a triangle. All right, let's move on. Number 6, find x in DEF. Well, DEF, it shows as a right triangle. It has these 2 labeled as the same measure. They're both 6. So this is our 45, 45, 90 special right triangle. And in that triangle, if we have a 45, 45, 90, and we know our legs, the hypotenuse is our leg times the square root of 2. So if these are 6, this is 6 square root 2. That's G. All right. Let's move this on up. Clear this off. All right, that's the bottom. So now we just did what number? We just did this one, right? That's where we left off. Circle those last 2 answers again, just so they're up there. Number 7. We got our 45, 45, 90 triangle again. Let me redraw that one more time. So in our 45, 45, 90, if these 2 legs are x, and the hypotenuse is x radical 2, and they tell me that the hypotenuse is 15 radical 2, then the 2 sides are 15. Again, you don't have to do any work there. You just have to remember that property. On number 8, the length of the sides of a square is 10 meters. Find the lengths of the diagonals of the square. All right, a little more challenging, but it's actually the same idea, because if I have a square and I draw in a diagonal, these were 90-degree angles, I split them and they both become 45. So I'm still dealing with that same triangle. They told me that the length of the sides of the square are 10. So what is this diagonal going to be? 10 square root of 2, same property. That's G. On 9 and 10, now we have our 30, 60, 90 triangle. All right, let me draw a diagram of that off to the side here. Use a different color. So again, our 30, 60, 90, 30, 60, 90. Everything's based off the short leg, which is X. The hypotenuse is the short leg times 2, so 2X. And I might have said that wrong. The short leg is X, the hypotenuse is 2X. It's double the short leg. The long leg is the short leg times square root of 3. So those are our 3 pieces. Coming back to the problem, they gave me the short leg on the first one. I know it's the short leg because it's across from the 30. They want the hypotenuse. Well, if my hypotenuse is double the short leg, 5 times 2 is 10. My answer for number 9, which is C. And then on number 10, we have the hypotenuse given to us. Well, we can't go from the hypotenuse straight to the long leg, which is what they're asking for. We have to go to the short leg first because everything's based on the short leg. So if the hypotenuse is 50, what's the short leg? And then if the short leg is 25, the long leg is 25 square root of 3. Good. Any questions on those? All right, I'm going to save that and erase it. Clear. On to the next page. All right, let's get that up just a little bit. On number 11, we have find X to the nearest tenth. Well, now we're not dealing with our special right triangles anymore. Now we're dealing with our trig ratios. So if you need to, write them down somewhere. So I'm going to write it off to the side. Some old hippie caught another hippie tripping on acid. What does that stand for? SOH is sine equals opposite over hypotenuse. CAH, cosine equals adjacent over hypotenuse. And TOA, tangents equal to opposite over adjacent. So on the first one, find X to the nearest tenth. Well, they gave me this angle at the top. So using that angle, I'm going to label what 2 pieces I have. 20 is across from the right angle, so that's my hypotenuse. X is across from the 67, so this is the opposite side compared to that angle. So I have opposite, I have hypotenuse. Opposite hypotenuse is sine. So we have sine of 67 degrees equals opposite, which was X, over hypotenuse, which was 20. Multiply that 20 out of our denominator. And that's what we're typing into our calculator. So again, type this into the calculator. If you need to, you could do sine of 67 first and then multiply by 20. Again, just be careful as you type it in. Also, on your calculator, you need to make sure it's in degree mode before you even start typing, or it's not going to work. So on here, if you type that in, we have 20 times sine of 67. And most of your calculators, you're going to have to hit 67 first, hit sine, you'll have a decimal, and make sure you hit the equal key in order to get the final answer. So that's 18.47. Now, look at my answer choices. That is answer choice C. All right, number 12. Find the measure of the angle of elevation. Let's see. Find the measure of the angle of elevation of the sun when a pole 25 feet tall casts a shadow 42 feet long. There. Okay, so we got to draw our figure here. We don't have a diagram to go off of. Different color. We'll do it over here off to the side. So we got our sun. Beautiful sun. We have a pole. Pole. We have a shadow. And then the angle up to the sun. So we have this, shows a right triangle here. The pole is 25 feet tall. The shadow is 42 feet long. We want the angle of elevation. So put the X in there. Now, what pieces do we have? Well, based on X, the 25 is our opposite. The 42 is our adjacent. Which one of our things uses opposite and adjacent? That's tangent. So we have tangent. Oops. Tangent equal, of X. I got my X there. Equals opposite, 25, over adjacent, 42. We need to get X by itself. So we're solving for an angle. We need to get rid of tangent. The way we get rid of tangent so that we can get the angle measure is the inverse tangent. So we're going to do inverse tangent of both sides, which is going to leave us with the inverse tangent of 25 over 42. Plug that into our calculator. Let me see if I can get my calculator up there on the screen. So again, as you're doing this one, we have 25 over 42. You can do that one of two ways. Either actually type in 25 divided by 42. If you do it this way, you must hit equals first. So you already have the answer of 25 over 42, and then do inverse tangent, which is going to give us an answer of 30.76. Now, if we do this a different way, let me move this out of the way. This is my drawing. If we do this a different way, we could also use our fraction key, which is down the bottom left of that calculator. 25, fraction key, 42. You don't have to hit equals now because it's already in there as a fraction. And then second, inverse tangent. Gives you the same answer. Again, the answer, if we look up at our choices, is F. Yeah, that is in degrees because that is an angle measure. All right, moving on. 13. Which angle of depression in the figure at the right? We have angle. Depression is going down from a horizontal. So this is depression. Elevation is going up. That's elevation. They wanted angle of depression. So this would be AOT, which is option A. Now, on that page, that's all I asked you to do. I didn't ask you going further because the rest of these go on to do things in sections that we did not cover. So the rest of it's not dealing with right triangles. So any questions on the ones we've done so far? All right, then let me clear this and I'll do the back real fast. The back, again, did not have any answer choices. Whoa, there we go. And it was all free response. So I made it a little bit more challenging, but all the questions were on similar ideas. Since I chose to give you guys Form C from this old book, Form C is a little bit more challenging. So some of the problems were a little bit higher order thinking, but they were still based off the same material. Let's start with number 1, find the geometric mean of 2 and 5. That's going to be straightforward no matter what we do. It's just the square root of the product. 2 times 5 is 10. So our answer here is the square root of 10. You can't simplify that one. So it's just going to stay square root of 10. On number 2, this one we have our properties for our geometric mean. I gave you the formulas that we could use before. Well, we're given an altitude. So first on this one, we're going to use our formula for altitude, which uses part 1 and part 2. Well, we don't have anything labeled for part 2, so I'm going to call that part Y for right now. So 4 will be part 1. Y is going to be part 2 for me. So I can do my formula. Altitude equals the geometric mean of part 1 times part 2. All right. Altitude was 6. Part 1 is 4. Part 2, I'm going to call Y for now. And we're taking square root. In order to solve this, get rid of the radical by squaring both sides. We get 36 is equal to 4y. Divide off 4. And y is 9. So we know what y is. So this piece is 9. 4 and 9, that's going to give us x. So 4 plus 9 is 13. And that's our answer for number 2. On number 3, this one, now x is on a leg. And when we do the leg, the formula calls for, let me use a different color here. So this is our leg. The formula calls for the adjacent part and the whole. So this part, I'm going to label as part 1. That'll be our adjacent part to that leg. And this will be the whole hypotenuse. So the formula again calls for leg is equal to the geometric mean of the adjacent part times the whole hypotenuse. So the leg here was x. The adjacent part was 2. The whole, if we add those together, 2 and 12 is 14. So x equals the square root of 28. Square root of 28. Can I simplify that? Let's see. 4 goes into 28, right? So that's 4 times 7. Square root of 4 is 2. This is 2 radical 7. All right. On number 4, we have 20 and 16. And got to find x. So we're going to plug those into Pythagorean theorem because this is a right triangle. All right. So x is our c value. So c squared equals a squared plus b squared. So x squared equals 400 plus 3600. X squared equals 4,000. Take the square root of both sides. Let's see. I can break that down. I can take out 400. That's 400 times 10. 400 is a perfect square of 20. So that's 20 radical 10. Square root 10. All right. On 5, again, we have ourselves an equilateral triangle. Now, we could do Pythagorean theorem. However, there is another faster way to do this because if I have an equilateral triangle, this is actually a 30, 60, 90 right here. So I had 20. This piece is 10. This is my long leg, and my long leg is 10 square root 3. Again, could have used Pythagorean theorem, but that would require me to, again, end up solving a radical and simplifying it, which would take more time. So if you can recognize the 30, 60, 90 triangle there, you can use it. Number 6, same thing. We have a square. So you can recognize this one as a 45, 45, 90 triangle. If that's 22, now going backwards, our property here was to divide off square root of 2. Well, if I divide by square root of 2, anytime I divide by a radical, it's the same as dividing by what's underneath the radical and multiplying by the same radical. So what's 22 divided by 2? That's 11. So this is 11 square root 2. In the parallelogram, they give us that AD is 4. They tell us that angle D is 60, and they want us to find AF. Well, again, this is a 30, 60, 90 triangle. They gave us the hypotenuse, so the short leg would be half of it. The long leg is going to be the short leg times square root of 3. And using our properties, using our formulas. You need to know those formulas, you know those patterns. Number 8, they wanted both X and Y. Well, both of these are special right triangles. So you can do this a couple different ways, but since we have a special right triangle here, we know this is our hypotenuse. Based on the hypotenuse, the short leg has to be half. So this part is going to be 2 radical 3. The long leg is going to be this one times the square root of 3. Now there's already a radical there, so it's actually going to eliminate that radical. So 2 radical 3 times square root of 3. So what we have here is this. That becomes just 2 times 3, which is 6. So X is 6. That's the first half. Once we know the short leg in this one, because now this is the short leg for the other triangle, the hypotenuse is doubled. So Y will be 12. Questions on those? Again, you got to know those formulas to do those. Clear that off. Let me move this up real quick. I know we're almost out of time. All right. On this one, round to find X to the nearest 10th. So I have this angle. I'm going to use sine, cosine, tangent. So again, write it out. Some old hippie caught another hippie tripping on acid. We have adjacent. We have hypotenuse. So plugging it in, we have adjacent hypotenuse is cosine of 18. I will post the rest of this online. So I'm making a video right now and I will post it. We have X. Oh, sorry, I lied. We have adjacent going on top, so that's 9.2 over X. To solve on this one, we are going to have to multiply both sides by X. Get X out of the denominator first. We have X times cosine of 18 equals 9.2. To get X by itself, you're going to have to divide off that cosine of 18. So cosine of 18 goes on bottom, cancels out. So now X is found by plugging this into our calculator. So on the calculator, 9.2 divided by cosine of 18. So I'm going to plug in 18, hit cosine, and I got to make sure I hit equals, and we get 9.67. All right. They said round to the nearest 10th. So that's 1 decimal place. So our final answer here will be 9.7. Number 10, an A-frame house is 40 feet high and 30 feet wide. Find the measure of the angle that the roof makes with the floor round to the nearest degree. All right. Well, on here, they gave us this piece. So that's 40. This is split in half, so that's 15. Now, we have 15 and 40. That's for a second, I thought that might be a triple, but I don't think it is. All right, let's see, plug it in to find that angle measure. We got opposite and adjacent given to us. All right, this is opposite and adjacent, and I'm guessing that's going to be the bell. All right, that's tangent. Have a good day. Like I said, I'll post the rest online. So again, tangent of x equaled 40 over 15. We have to take the inverse tangent to get the angle by itself. So plugging it into the calculator, we would have 40 divided by 15, if you do it this way, equals second inverse tangent, which is 69.44. They said to the nearest degree, so just round it off to 69 degrees. If we did it the other way, type it in as a fraction, 40 over 15, and then second inverse tangent, same answer. All right, let me do this one real quick, and then I'm going to pause this recording so I can let my next class in, and we'll finish the last few problems. Number 11, a 30-foot tree casts a 12-foot shadow. Find the measure of the angle of elevation of the sun to the nearest degree. So we have our tree, we have our shadow. It's a 30-foot tree. Oops, 30 foot. They said it's a 12-foot shadow. They want angle elevation. This is going to be opposite and adjacent. So we're using tangent again. Tangent of x equals 30 over 12. This is almost exactly the same as the last problem. We're doing inverse tangent of 30 over 12. And when we do that, we plug it into the calculator. 30 over 12 inverse tangent. That's going to give us 68.1985 said to the nearest degree, so 68 degrees. All right. Save that, clear it. Move it on to the next screen. Let's see, we only have those two left at the top, so I'll continue this in just a minute. Let me pause this recording. All right, so guys, I do need you to, all right. So again, on number 12, all right, so I'll go back and show you guys the rest in this fast period in just a minute, but just finishing off this recording. For number 12, again, this section was doing sine, cosine, and tangent. So if you need to, you can write that down off to the side every time you need it. So on here, again, sum, sorry, that messed up. Some old hippie caught another hippie tripping on acid, which again stands for sine equals opposite over hypotenuse, cosine equals adjacent over hypotenuse, tangent equals opposite over adjacent. So now on number 12, a boat is 1,000 meters from a cliff. So here's my boat, here's my cliff. The angle of depression from the top of the cliff to the boat is 15. That's not labeled on here, so I should draw it in. But if they give me angle of depression, that means I also have the angle of elevation. So I could also put 15 in this corner. How tall is the cliff? Round your answer to the nearest tenth. So look at this figure. I'm using this angle measure to label the pieces I have. So this is going to be my adjacent side. And then the part they want me to find over here, the cliff, which I'm going to call X right now, That's going to be my opposite side. So opposite and adjacent, what's that going to be? Well, again, looking at my ratios, O and A, that's part of T. So this is going to be tangent. So tangent of my angle, 15, is going to be equal to opposite over adjacent. I need to solve that. Well, I have the 1,000 on bottom. So in order to solve this, we can multiply it off of the bottom times 1,000. So it cancels out over here. And then we're going to get our answer from plugging that into our calculator. So on our calculator, we can say 1,000 times tangent 15. So 1,000 times tangent of 15. Now, on this calculator, again, typing in the 1,000, I'm multiplying by 15, hitting tangent, that's tangent 15. I have to enter before I get my final answer, which in this case was 267.94. So 267.949. And they said round to the nearest tenth. So if I round to the nearest tenth, I'm just going to round it off to that 0.9. So 267.9. And this answer was in meters, since the other measurements were also in meters. Number 13. A plane is flying an altitude of 1,000 feet, begins descending. When the end of the runway is 50,000 feet from a point on the ground directly below the plane, find the measure of the angle of descent to the nearest degree. So yes, sometimes. All right, so here's the ground. Here's my plane. It's not going to look very good. All right, there's my plane. Now, they gave me measurements. Let's see, a plane flying at an altitude of 10,000 feet. So this is 10,000 feet. Begins descending when the end of the runway is 50 feet from a point on the ground directly below it. So the end of the runway. So let's say here's the runway over here. Here's the point below the plane. It says we have 50,000 feet left from that point directly below it to the runway. So we have ourselves our right triangle. Now, they want us to find angle of descent, which they put in parentheses is our angle of depression. So we draw a line here. So this is what they're actually asking us to solve for, that x, which would be the same thing as the angle of elevation from the runway up to the plane. So now that I have a diagram, I'm using this angle. I have the opposite. I have the adjacent. I need to find that angle of elevation, which is again also the angle of depression. So opposite and adjacent, that is tangent. Tangent of the angle is what we're finding, equals opposite, 10,000, over adjacent, 50,000. And in order to solve this, again, in order to get rid of tangent so that we're solving for an angle measure, that's where you do the inverse operation. So we're doing the inverse tangent of 10,000 over 50,000. And that's what's giving us x. So plug it into the calculator. 10,000 Now you could say divided by 50,000. If you do it that way, you have to equals first, and then second inverse tangent. So our angle here says 11.3099. Said round to the nearest degree, so that's just 11. So this is 11 degrees for our final answer. The other way you can do it on the calculator is, if we left it as a fraction, 10,000 fraction key 50. Ooh, I can't type that into this calculator because they're too long of numbers. Now, some calculators you could. If you wanted to, you could count out some zeros first. So we could have done 10 over 50, all right, or even 1 over 5, and then done inverse tangent of that. Still gets us the same answer. So you can also reduce that fraction if you need to. So, different ways of doing that. All right. I said that the next ones you did not have to do. So on this back side, the only other one that I said you could do was the one that said bonus at the very bottom. So let me go ahead and clear this, and I'm going to scoot this paper up to the bottom. Let's see what that bonus one said. Move my calculator out of the way so I have more room to write. Now we have find x. They gave us a couple of pieces here. They gave us a leg. So we can use our formula for a geometric mean for finding a leg. The leg is equal to the geometric mean of the adjacent part times the whole. Let's see. Oh, that'd be why this was a bonus. Okay. Probably shouldn't have given this one to you guys, but I'll show you the work anyway. And I'll show you why I shouldn't have given it to you. All right. So this was x. The whole here was x plus 5. All right. So if we're doing this problem and plugging it in, I had the square of 6 going in for the leg. I had x. Actually, this might not be as bad as I was thinking it was. We had x for the adjacent part. We had the whole is x plus 5. And then we needed to solve. So in order to solve and get x by itself, first thing we can do is get rid of these square roots. So square both sides. That'll get these square roots to cancel off. So now we have 6 is equal to x times x plus 5. Which, no, this was a bad problem because this is going to lead into quadratics, and we haven't done anything with quadratics this year. So this gives us x squared plus 5x. All right. Yeah, don't really want to do this problem. Do you want me to work this out the rest of the way? Do you want an answer even? I'm not going to give you a quadratic on this test. Just to recap from algebra, though, if we were to solve this out all the way, we would need to bring the 6 over to the other side. It's not a horrible problem to do. Then we'd have to factor. So we have it set equal to 0. We'd have to factor to solve. Find factors of negative 6 to add to 5. That would be negative 6 and 1. Sorry, 6 and negative 1. Then solve each of those separately. And then x would be either a positive 1 or it'd be a negative 6. Since we're talking about distance, it can't be negative. So our answer here is 1, which, like I said, I don't want to confuse you guys too much. We're not doing anything with quadratics yet. We will have some problems later in the year where we need to do a quadratic, but we haven't gone back over those at all yet. All right, that's it for that. Let me save this real quick. and then I'll go back to the beginning, give you guys the rest of the answers here. So let me end this.